effort required to perform a task. But in the notion of physics, it depends on the idea of a force, which is a push or pull. Force is modeled by the equation mass times acceleration. So that's how we achieve force. But in the case of constant acceleration, work is equal to the force times the displacement. So work is equal to F times D. Now, force is commonly, with the scientific community's accepted units, is the Newton. And displacement is modeled in terms of the meter, thus giving us work of the Newton meter, or the joule. These are both the same term, it just describes the Newton meter. They decided to simplify it so they could put J at the end instead of being all complicated. In the US, with our system, the force would be in pounds, and the distance would be in feet, which would give us foot-pounds. But today we're just going to stick with Newton meters because it's a little bit less confusing. Okay, so an example of this equation would be a cart is pushed along a straight line with a force of 2.0 newtons for 12 meters. Now the straight line aspect is important because that lets us know that this is, the 12 meters is for certain the displacement. So clean this up a bit. We know that the force is the 2.0 newtons, and the displacement is the 12 meters. And then with our equation of work is equal to force times the displacement, that would be modeled by work is equal to, we plug them in, force is 2.0 newtons, and then the displacement is 12 meters, giving us a work of 24 Newton meters, or 24 joules. And there you have it.
Unfortunately, constant acceleration and force is not always the case. So when variable force is introduced, total work can be approximated by work equals the integral of a to b of f of x dx, where f of x is the force function, and a to b represents the starting point and the ending point, which is overall displacement. Alright, for example, with the case of variable force, the force can be defined by the force function f of x as being x squared in this situation. And it will be pushed from 0 to 3 meters. In calculating the work in this situation, W will equal the integral from 0 to 3, which is the starting point at 0 and the ending point of 3 meters, times the force function, or of the force function, which is x squared, and then dx, as it is an integral. Therefore, we must take the antiderivative of x squared. And to do that, we take x up to the next power, so x to the third, times 1/3, as 3 times 1/3 equals 1, which gives us the x squared. And in this situation, we must then evaluate it from 0 to 3 to get the full work. And to do that, we just plug in 3 and subtract after we plug in 0. So we get 1/3 times 3 to the third minus 1/3 times 0 to the third. And that's just 0, so that can be canceled out right away. Then in this case, we get 3 cubed, which is 27, times 1/3, which gives us an answer of 9 Newton meters, as the forces are defined above, or 9 joules.